and no problems to solve. All of those things belong to the day, and the day has finished its work. Now, it is time for the night. It is time for the quiet observation of things that are much larger, much older, and much calmer than we are. Tonight, we are going to drift through our cosmic neighborhood. We are going to gently review 100 quiet, unassuming facts about the solar system. There is no test at the end of this. You do not need to remember any of these numbers or names. If your eyes grow heavy at fact number 10 or 20, simply let them close. Let my voice become just another frequency in the room, guiding you toward a deep, restorative sleep. Take a deep breath in and let it out slowly. Let us begin our drift into the dark, starting at the very center.
The sun, the silent hearth. Our journey begins with the anchor of our existence, the sun. It is a yellow dwarf star, a nearly perfect sphere of hot plasma, sitting quietly at the center of our solar system. It is so massive that it accounts for 99.86% of the total mass of the entire solar system. Everything else, every planet, every moon, every asteroid, and every comet combined makes up less than 0.2%. Consider the sheer scale of it. The diameter of the sun is about 864,000 miles. This is 109 times the diameter of Earth. If the sun were a hollow sphere, you could fit roughly 1.3 million Earths inside it, packed tightly like marbles in a jar. Despite its immense power, the sun rotates slowly on its axis. Because it is not a solid body, but a ball of gas and plasma, it rotates at different speeds. At its equator, it takes about 25 Earth days to complete one rotation. But at its poles, the rotation is much slower, taking more than 35 days to turn once. This differential rotation twists the sun's magnetic fields, creating the quiet but powerful phenomena we know as sunspots. Deep inside the sun, in the core, the temperature reaches 27 degrees Fahrenheit. Here, in the crushing dark and heat, nuclear fusion turns hydrogen into helium. This process releases energy, but this energy does not escape immediately. A photon of light created in the core can take up to 170,000 years to migrate through the radiative zone to the surface. It bounces around, absorbed and re-emitted countless times before it finally reaches the photosphere. Once that photon reaches the surface, it takes only 8 minutes and 20 seconds to travel the 93 million miles across the vacuum of space to reach your eyes on Earth. The Sun is middle-aged. It formed about 4.6 billion years ago from the collapse of a giant molecular cloud. It has burned through about half of its hydrogen fuel. It will continue to burn, steady and bright, for another 5 billion years, watching over the planets as they sleep.
We drift now, moving outward from the star to the first planetary outpost. This is Mercury. It is the smallest planet in the solar system, only slightly larger than Earth's moon. It is a desolate, quiet world, scarred by billions of years of cosmic impacts. Because Mercury has virtually no atmosphere to retain heat, it experiences the most extreme temperature fluctuations of any planet. During the day, under the glare of the nearby sun, surface temperatures can reach 800 degrees Fahrenheit. But as night falls, without a blanket of air to hold the warmth, the temperature plummets to minus 290 degrees Fahrenheit. Mercury spins very slowly. It rotates on its axis once every 59 Earth days. However, it orbits the Sun very quickly, completing a year in just 88 Earth days. This creates a unique resonance. On Mercury, one solar day, the time from noon to noon, lasts 176 Earth days. If you were standing on the surface, you would watch the Sun rise, stop in the sky, move backward briefly, and then set, all over the course of months. The surface of Mercury is gray and rocky, covered in a layer of dust and broken rock called regolith. It is dominated by a massive impact crater known as the Caloris Basin. This basin is 960 miles wide, created by an asteroid impact so powerful that it sent shock waves through the entire planet, creating chaotic, jumbled terrain on the exact opposite side of the world. Despite being the closest planet to the Sun, Mercury is not the hottest. And surprisingly, in the permanent shadows of deep craters at its north and south poles, radar scans have revealed the presence of water ice. Hidden from the Sun for billions of years, these pockets of ice sit in eternal darkness and cold. Venus, the veiled world. Drifting further out, we approach the second planet, Venus. It is often called Earth's twin because they're similar in size and mass. Venus is only about 400 miles smaller in diameter than Earth, but the similarities end there. Venus is wrapped in a thick, toxic atmosphere composed mainly of carbon dioxide, with clouds of sulfuric acid droplets. This thick atmosphere creates a runaway greenhouse effect. It traps the heat from the Sun so efficiently that Venus is the hottest planet in the solar system, with a surface temperature of nearly 900 degrees Fahrenheit, day and night. The air pressure on the surface is crushing, 92 times greater than that of Earth. Standing on Venus would feel like standing 3,000 feet underwater in Earth's oceans. Venus is a rebel in its motion. While most planets rotate counterclockwise on their axis, Venus rotates clockwise, a phenomenon known as retrograde rotation. This means that on Venus, if you could see through the clouds, the sun would rise in the west and set in the east. Its rotation is also incredibly slow. It takes 243 Earth days for Venus to spin once on its axis, but it takes only 225 days to orbit the Sun. This means that a day on Venus is actually longer than a year on Venus. The surface of Venus is a dry desertscape of slab-like rocks and volcanic plains. It has more volcanoes than any other planet in the solar system. Over 1,600 major volcanoes, and perhaps hundreds of thousands of smaller ones. The highest mountain on Venus is Maxwell Montes, standing 7 miles tall, cooler and quieter than the baking plains below. Because Venus has no moon and no magnetic field to protect it, the solar wind strikes its upper atmosphere directly, slowly stripping away lighter gases into the void, leaving the heavy, slow-moving atmosphere behind. Earth, the blue marble. We continue our drift to the third rock from the sun, our home, Earth. It is the only planet we know of where water exists in liquid form on the surface. 71% of the surface is covered in ocean. From space, it appears as a brilliant blue marble swirled with white clouds. Earth travels through space at a speed of 67,000 miles per hour, yet we feel nothing. The motion is smooth, constant, and silent. We are protected by a thin layer of gases, mostly nitrogen and oxygen, that we call the atmosphere. This layer is incredibly thin compared to the size of the planet. If Earth were the size of an apple, the atmosphere would be thinner than the skin of that apple. Earth is the densest planet in the solar system. It is composed of iron, oxygen, silicon, and magnesium. Deep beneath our feet, the planet is differentiated into layers: a solid inner core of iron, a liquid outer core that generates our magnetic field, a thick mantle of flowing rock, and a thin, brittle crust upon which we sleep. The magnetic field is invisible but vital. It reaches out thousands of miles into space, deflecting the harmful radiation of the solar wind. When these solar particles are trapped near the poles, they interact with the atmosphere to create the auroras, the northern and southern lights, silent curtains of green and violet dancing in the thermosphere. Earth is not a perfect sphere. Because of its rotation, it bulges slightly at the equator. The diameter at the equator is 27 miles wider than the diameter from pole to pole. This shape is called an oblate spheroid.
The moon, the silent watcher. Orbiting our blue planet is the moon, our only natural satellite. It is about 1/4 the size of Earth. The moon is tidally locked to Earth, which means it rotates on its axis at the exact same speed that it orbits our planet. Because of this synchronous rotation, we only ever see one side of the moon. The far side remains forever turned away from us, gazing out into the deep black of the universe. The distance between Earth and the moon averages about 239,000 miles. This distance is deceptive. you could fit all the other planets in the solar system: Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune, neatly into the space between Earth and the Moon, with a few thousand miles to spare. The Moon is slowly drifting away from us. Every year it moves about 1.5 inches farther from Earth. This drift is caused by the tidal energy transfer between the Earth's oceans and the Moon's gravity. Billions of years ago, the Moon appeared much larger in our sky. In the distant future, it will appear merely as a bright star. The surface of the Moon is covered in fine charcoal gray dust called lunar regolith. It smells like spent gunpowder. Footprints left by astronauts in this dust will remain undisturbed for millions of years, as there is no wind to blow them away and no water to wash them away. They sit in perfect silence. There are dark patches on the Moon called Maria, which is Latin for seas. Early astronomers thought they were bodies of water. We now know they are vast plains of solidified basaltic lava from ancient volcanic eruptions that occurred when the Moon was young and molten. Mars, the red desert. Leaving the Earth and Moon behind, we drift outward to the fourth planet, Mars. It is a cold desert world, about half the size of Earth. Its reddish color comes from iron oxide, rust, distributed throughout the dust that covers the surface. Mars has a very thin atmosphere, composed mostly of carbon dioxide. It is about 100 times thinner than Earth's atmosphere. Because it is so thin, it cannot trap heat. The average temperature on Mars is -80 degrees Fahrenheit. It is a quiet, frozen place. Despite the cold, Mars is home to the largest volcano in the solar system, Olympus Mons. It is a shield volcano, with a slope so gradual you would barely notice you were climbing it. It stands 16 miles high, nearly 3 times the height of Mount Everest. Its base is the size of the state of Arizona. It has been silent for millions of years. Mars also possesses the largest canyon system in the solar system, Valles Marineris. This canyon runs for 2,500 miles along the Martian equator. It is 4 times deeper than the Grand Canyon on Earth. If placed on the United States, it would stretch from New York to Los Angeles. The Martian day is very similar to ours. It is called a sol and lasts 24 hours and 39 minutes. The axial tilt of Mars is also similar to Earth's, which means Mars experiences seasons. But because its year is almost twice as long as ours, 687 Earth days, the seasons last twice as long. Winter on Mars is a long, dark time, where carbon dioxide freezes out of the air onto the polar caps. Currently, the surface of Mars is inhabited only by robots: the Perseverance rover, the Curiosity rover, and the landers that have ceased to function. They sit in the red dust, enduring the silent winds and the pale pink sky. Mars has 2 small potato-shaped moons named Phobos and Deimos. They are likely captured asteroids. Phobos orbits so close to Mars that it rises in the west and sets in the east twice each day. It is slowly spiraling inward. In about 50 million years, it will either crash into Mars or break apart to form a ring.
The asteroid belt, the drifting rocks. Between the rocky inner planets and the gas giants lies a vast sparse region known as the asteroid belt. It is not crowded like the asteroid fields in movies. The distance between objects here is immense, often millions of miles of empty vacuum. There are millions of asteroids here, remnants from the early formation of the solar system that never coalesced into a planet. Despite their numbers, the total mass of the entire asteroid belt is less than 4% of the mass of our moon. The largest object here is Ceres. It is the only dwarf planet located in the inner solar system. Ceres is roughly 580 miles across. It is spherical and contains a large amount of water ice beneath its crust. Bright spots on its surface are deposits of sodium carbonate, salt, left behind when salty water sublimated into space. Then there is Vesta, the second largest object. It is not quite round. It bears a massive scar at its south pole, a crater called Rhea Silvia. The impact that created this crater was so enormous that it ejected 1% of Vesta's mass into space. Some of those meteorites have fallen to Earth, telling us the story of Vesta's violent past. These rocks drift silently in the dark, tumbling slowly, freezing in the shadow and baking in the weak sunlight, circling the sun in a loop that takes years to complete. Jupiter, the gas giant. We cross the frost line now. We are entering the realm of giants. Ahead of us looms Jupiter, the largest planet in the solar system. It is massive enough to hold more than 1,300 Earths inside it. It acts as a cosmic vacuum cleaner, its immense gravity attracting comets and asteroids, protecting the inner planets from bombardment. Jupiter is not a solid world. It is a gas giant, composed mostly of hydrogen and helium, swirling in complex bands of clouds. These clouds move at different speeds and in different directions, driven by internal heat and fast rotation. Jupiter spins incredibly fast for its size, completing a day in just under 10 hours. This rapid spin causes the planet to bulge significantly at the equator. The most famous feature of Jupiter is the Great Red Spot. It is a massive anticyclonic storm, a high-pressure region that has been raging for at least 400 years. It is large enough to swallow Earth whole. The winds at the edge of the spot scream at nearly 400 miles per hour, but in the center, it is relatively calm. Deep beneath the clouds, as the pressure mounts, hydrogen gas is squeezed until it becomes a liquid. Deeper still, the pressure is so intense that electrons are stripped from the hydrogen atoms, creating a substance called metallic hydrogen.
This electrically conducting fluid swirls in the deep dark, generating the most powerful magnetic field of any planet. Jupiter is a miniature solar system unto itself, with 95 known moons. The 4 largest are known as the Galilean moons. There is Io, the most volcanically active body in the solar system, tortured by Jupiter's gravity. There is Europa, covered in cracked ice, hiding a global ocean of liquid water beneath the surface that contains twice as much water as all of Earth's oceans combined. There is Ganymede, the largest moon in the solar system, bigger even than the planet Mercury. And there is Callisto, an ancient cratered ball of ice and rock, the most heavily cratered object in the solar system. These moons dance in a precise rhythm around the giant, silent and obedient to the laws of gravity.
Saturn, the jewel of the solar system. We leave the realm of the king of planets and drift nearly 400 million miles further into the dark. Ahead, suspended like a pendant in the velvet night, lies Saturn. It is arguably the most beautiful object in our sky. Saturn is a gas giant, second in size only to Jupiter. It is composed of 96% hydrogen and 3% helium. Despite its immense size, 9 Earths could span its diameter. Saturn is incredibly light. It is the least dense planet in the solar system. In fact, its density is lower than that of water. If you could build a bathtub large enough to hold it, Saturn would float. The winds on Saturn are ferocious, far stronger than those on Jupiter. Near the equator, wind speeds can reach 1,100 miles per hour. Yet from this distance, the planet appears perfectly still, a pale gold sphere banded with soft hues of beige and brown. At the planet's north pole, there is a geometric curiosity that has persisted for decades. It is a perfect hexagon. This 6-sided jet stream is 20,000 miles wide. You could fit 4 Earths inside this hexagon. It rotates at the same speed as the planet's radio emissions, a silent, spinning shape in the clouds that scientists are still working to fully understand. The rings, a sea of ice. But the defining feature of Saturn is, of course, its rings. From Earth, they look like solid disks, like the rim of a hat. But up close, we see they are not solid at all. They are composed of billions of individual particles. These particles range in size from microscopic grains of dust to boulders as large as a house, and occasionally mountains of ice. They are made almost entirely of water ice, which is why they reflect sunlight so brilliantly. The ring system is massive, stretching up to 175,000 miles from the planet. However, they are astonishingly thin. On average, the main rings are only about 30 feet thick. If you were to build a scale model of Saturn where the planet was 3 feet wide, the rings would be 10,000 times thinner than a razor blade. Because they are so thin, every 15 years or so, as Saturn orbits the Sun, The rings align edge-on with Earth. When this happens, they seem to vanish completely, leaving Saturn looking lonely and bare, before slowly tilting back into view. There are gaps in the rings. The largest is the Cassini division, a region nearly 3,000 miles wide that appears empty. But it is not truly empty. It is just less dense, cleared out by the gravitational pull of a tiny moon called Mimas. This is the rhythm of the Saturnian system, a delicate balance of gravity and motion, maintained for millions of years.
Titan, the orange moon. Saturn has 146 moons, a chaotic swarm of ice and rock. But one stands out above the rest: Titan. Titan is the second largest moon in the solar system, larger than the planet Mercury. It is the only moon known to have a dense atmosphere. This atmosphere is golden orange and opaque, 4 times denser than Earth's atmosphere. It creates a permanent haze that hides the surface from view. If you were to stand on the surface of Titan, the sky would be a deep, murky orange. The sun would appear as a small, bright patch in the haze, providing only about 1/1000th of the daylight we experience on Earth. It would feel like deep twilight all the time. Titan is a strange mirror of Earth. It has clouds, rain, rivers, lakes, and seas, but the liquid is not water. The surface temperature is -290 degrees Fahrenheit. At this temperature, water is as hard as granite. The liquid on Titan is methane and ethane. It rains liquid natural gas on Titan. The drops fall slowly, drifting down in the low gravity, which is even weaker than our moon's gravity. The rain feeds vast hydrocarbon lakes near the poles, like Ligeia Mare and Kraken Mare. These lakes are calm. The Cassini spacecraft observed them for years and saw almost no waves. They are black, oily mirrors reflecting the orange sky, undisturbed by the wind. Uranus, the rolling giant. We drift now into the outer reaches, crossing a gulf of nearly 1 billion miles to reach the 7th planet, Uranus. Uranus is an ice giant. Unlike Jupiter and Saturn, which are mostly gas, Uranus is composed largely of heavier volatile elements, water, ammonia, and methane ices. The atmosphere contains methane, which absorbs red light and reflects blue-green light, giving the planet a serene, pale cyan color. It looks like a smooth, flawless aquamarine sphere suspended in the void. Uranus is the coldest planetary atmosphere in the solar system, with temperatures dropping to -371 degrees Fahrenheit. It creates almost no internal heat, making it a very sluggish,
quiet world. The most unique fact about Uranus is its orientation. While other planets spin like spinning tops, Uranus rolls on its side. Its axial tilt is 98 degrees. It is believed that a massive collision with an Earth-sized object billions of years ago knocked it over. This tilt creates extreme seasons. It takes Uranus 84 Earth years to orbit the Sun. For 21 years, the North Pole points directly at the Sun, bathing in constant daylight, while the South Pole lies in total darkness. Then, 42 years later, the situation reverses. If you lived at the pole of Uranus, you would experience a single day that lasts for 42 years, followed by a single night of equal length. Uranus also has rings, though they are dark and narrow, made of asphalt-colored particles that reflect very little light. They were not discovered until 1977, when they blocked the light of a distant star.
Neptune, the windy blue. Another billion miles outward, we find the twin of Uranus. This is Neptune, the eighth and final planet from the Sun. It is the most distant major planet, orbiting roughly 2.8 billion miles away from our star. From here, the Sun is just a pinprick of brilliant light, not a disk. It provides very little heat. Neptune was the first planet to be discovered by mathematics before it was seen by a telescope. Astronomers noticed that Uranus was moving strangely, pulled by an unseen gravity. They calculated where the hidden planet should be, pointed their telescopes, and there it was. Neptune is a vivid, deep azure blue. Despite being so far from the Sun and receiving so little energy, Neptune is surprisingly active. It has the fastest winds in the solar system, reaching speeds of 1,300 miles per hour. These winds are supersonic, whipping clouds of frozen methane across the planet faster than the speed of sound. Neptune possesses a storm system similar to Jupiter's, known as the Great Dark Spot. It is an anticyclonic storm the size of Earth. However, unlike Jupiter's spot, these storms on Neptune appear and disappear over the course of a few years. They are transient ghosts in the deep blue atmosphere. Orbiting this windy world is Triton, Neptune's largest moon. Triton is an oddity. It orbits Neptune in the opposite direction of the planet's rotation, a retrograde orbit. This suggests that Triton did not form with Neptune, but was a dwarf planet captured by Neptune's gravity long ago. Triton is one of the coldest objects in the solar system, with a surface temperature of -391 degrees Fahrenheit. Yet, it is geologically active. Voyager 2 observed cryovolcanoes, ice volcanoes, erupting plumes of nitrogen gas and dust 5 miles into the thin atmosphere. These plumes then drift sideways, carried by the weak winds, leaving dark streaks on the pinkish nitrogen ice of the surface. The Kuiper Belt, the twilight zone. Beyond the orbit of Neptune, we enter the Kuiper Belt. This is a vast, donut-shaped ring of icy bodies, similar to the asteroid belt,
but 20 times wider and up to 200 times more massive. This is the home of Pluto. Once considered the 9th planet, Pluto is now the king of the Kuiper Belt. It is a small world, smaller than Earth's moon. Its orbit is highly elliptical and tilted. It takes Pluto 248 Earth years to complete one lap around the Sun. Since its discovery in 1930, Pluto has not yet completed a full orbit. It will not do so until the year 2178. When the New Horizons spacecraft flew past Pluto in 2015, it revealed a surprisingly complex world. We saw a vast, heart-shaped glacier made of nitrogen ice named Sputnik Planitia. This glacier is churning slowly, like a pot of soup on a low simmer, driven by the modest heat from Pluto's core. There are mountains made of water ice that stand as tall as the Rockies, floating on the nitrogen sea. The atmosphere of Pluto is thin and blue. Yes, if you stood on Pluto and looked up, you would see a blue haze in the sky, layered in thin bands. When Pluto moves farther from the Sun in its orbit, this atmosphere freezes and falls to the ground as snow. When it moves closer, the snow sublimes back into gas. It is a planet that breathes very slowly over the course of centuries. It is so quiet here. The sunlight is weak, resembling the light of a full moon on Earth.
The Oort cloud, the edge of influence. We drift further still, leaving the planets and the belt behind. We are entering the region known as the scattered disk, and beyond that, the theoretical Oort cloud. This is a giant spherical shell surrounding our solar system like a thick bubble. It is made of billions, perhaps trillions, of icy debris the size of mountains. These are the sleeping comets. They float here in the absolute dark, loosely bound to the sun by the faintest thread of gravity. The Oort cloud is incredibly distant. It begins about 2,000 astronomical units from the Sun and extends perhaps as far as 100,000 astronomical units. That is nearly halfway to the next nearest star, Proxima Centauri. If you were in the Oort cloud, you would not know you were orbiting our Sun. It would look just like any other bright star in the sky. It would take a beam of light more than a year to travel from the Sun to you. Occasionally, a passing star or the tide of the Milky Way galaxy nudges one of these icy bodies. It begins a long, slow fall inward, taking thousands of years to reach the inner solar system, where it will warm up and become a comet with a brilliant tail, briefly visiting the warmth before swinging back out into the cold. The heliosphere, the final boundary. Our final fact concerns the bubble in which we all live. The Sun constantly emits a stream of charged particles called the solar wind. This wind blows outward, past Earth, past Jupiter, past Pluto, inflating a vast magnetic bubble in the interstellar medium called the heliosphere. This bubble protects us. It pushes back against the cosmic rays and interstellar gas of the galaxy. But it has a limit. There is a boundary called the heliopause.
This is where the pressure of the solar wind is finally overcome by the pressure of the galaxy. It is the official edge of the solar system. Only 2 human-made objects have crossed this line while still functioning: Voyager 1 and Voyager 2. Launched in 1977, they have been traveling for nearly 50 years. Voyager 1 is currently more than 15 billion miles away from Earth. It is traveling at 38,000 miles per hour. Despite this speed, it will take 40,000 years for it to pass close to another star. On board Voyager 1 is a golden record. It is a 12-inch gold-plated copper disc containing sounds and images selected to portray the diversity of life and culture on Earth. It holds the sounds of wind, thunder, birds, and whales. It holds greetings in 55 languages. It holds the brainwaves of a woman thinking about love. It is a message in a bottle, floating in the cosmic ocean. It is currently drifting through the interstellar medium, the space between stars. It is silent there. The plasma is dense but quiet. The probe is powered by a slowly decaying nuclear battery. One day, likely around the year 2025 or 2030, its instruments will turn off one by one to save power. Eventually, the transmitter will fall silent. The probe will become a dark, inert piece of metal and gold, carrying the memory of our existence into the endless void.
The fade out. We have drifted from the fiery core of the sun to the frozen silence of interstellar space. We have seen storms the size of worlds and oceans of liquid methane. We have seen the beauty of rings and the desolation of craters. The universe is vast, it is ancient, and it is patient. It does not demand your attention, it simply is. Everything we have spoken of tonight will still be there tomorrow. The planets will continue their slow orbits. The moons will continue their tides. The stars will continue to burn. You are part of this system. You are made of the same elements, the carbon, the nitrogen, the iron that make up these worlds. You are stardust that has learned to sleep. So now, let the gravity of your bed hold you. Let your breathing slow down, matching the rhythm of the tides. Drift, float, sleep. Good night.
Hello there. Welcome to Deep Sleep Science. I am glad you found this place. Before we begin our journey tonight, I invite you to take a moment to settle in. Adjust your pillows. Pull the blanket up to your chin or wherever it feels most comfortable. Let the weight of your body sink into the mattress. There is nowhere else you need to be right now. There are no emails to answer, no errands to run, and no problems to solve.